So this is Unit 1, Lesson 2. The unit is called Functions. The lesson is called Evaluating Functions from Graphs. What we're going to learn in this video is how to evaluate a function from a graph. And we're also going to learn about holes. So here's our formal technical terms. An ordered pair xy represents the input in the domain that is related to an output in the range. So x, the input, maps to some y value as the output. The relationship between each input and output can be determined by a function, in this case the function f of x. And so if we look at any value of x, the function f will tell us what y value that maps to. So -6 maps to -3, -2 maps to +2, and 2 maps to 3, according to f of x. So now a hole, this open circle on our function is called a hole. And what that means is that this line, this function line, will tell us where all of our x values map to their respective y values. However, the one exception is at this point we have a hole. The hole means that we omit 3, the x value 3 from our domain. Just bloop, get rid of it, it's gone. Which means that 3 is the only input that maps to the output of 3. So 3 is also omitted from our range. Bloop, is gone. However, anywhere else in this line, we have a mapping. Every input maps to a different output. 1 maps to 2, 2 maps to 2.5. We don't have 3. We have 2.9 would map. We have 3.1 would map, just not 3 because of this hole. Let's talk about some examples. Alright, so here's a function f of x is defined by these 5 points, a, b, c, d, and e. So we can use these points to evaluate f of x. So f of 1, 1's right here, so a is going to tell us f of 1 maps to -2. So f of 1 equals -2. Let's see here, b tells us that f of 3 maps to 3. So f of 3 equals 3. And -2 is point D will tell us that -2 maps to -2, the output. And if we look at f of, for funsies, if we look at just f of 6, there's no dot above f of x equals 6, and there's no dot below x equals 6. So we have no definition for this input, as in there's no definition as what this should map to, what output it should go to. So in our mapping, there could be a 6 in the domain, but it would have no arrows coming out of it. So f of 6 in this case would be undefined. So we say that it's not defined. All right, so here's a graph of a different f of x. Looks like a parabola. We can evaluate all these values: f of 1, f of -2, f of -3, 3.5, and 5. So just take a moment. Feel free to pause the video if you need to, and just double check each of these outputs and make sure they make sense to you. All right, so here's another f of x function. And this graph is a little nastier. We've got a bunch of holes going on. We've got a bunch of different chunks. We've got like a flat line. We've got like a section of a parabola looking thing. We've got another line. We got lot going on. If I look at -5, this input maps to -5, so f of -5 equals -5. If I look at f of 2, where does 2 map to? We have a hole and we have a dot. So the hole doesn't give us any definition for 2, but the dot does. So we're going to say f of 2, because this dot is right here, f of 2 is going to map to the output of 5, where f of 2 is 5. F of 4 has a hole but no dot, so there's no definition for this input. So f of 4 is going to be undefined. F of 6, that's about 3. If you look really close, you can see it's a little bit higher than 3. But right now, because we're looking at the graph, we're just kind of estimating. So at this point, from a graph, it's totally okay to kind of just round that to 3. If you put 3.1 or something close to that, that would be acceptable as well. F of -1, so -1 maps to 3. F of -2. Again, we have a hole below -2, and we've got a dot above -2. So the dot's going to tell us that F of 2 um, maps to the output of 4. F of 2 equals 4. -6. -6 maps to -5. And -4 also maps to -5. So F of -5, F of -6, F of -4 all map to -5 because this is a flat line. Boom, boom, boom. So takeaways. From this lesson, we know that we can use graphs to evaluate functions. These evaluations from the graphs are just estimates. They're not super precise. We can get better, more precise answers down the road, but right now, estimates are fine. And we also now know what a hole looks like on a graph. Or you could say we have a whole lot more understanding of holes. That was so cheesy. So I'm just going to end the video now.